Okay, so my lesson topic is the derivatives of polynomial functions. So first and foremost, first derivatives are equations that help us find the tangent slope at any value of x of the original function. For example, if the derivative is set to 0 and we solve for x, we are looking for a potential local max or min. So some important terminology that you're going to need for this unit is the power rule. So if f at x to the power of n, where n is a real number, then f prime equals nx to the power of n minus 1. Another one is the constant function rule. So if f at x equals k, where k is constant, then f at prime of x equals 0. The next one is the constant multiple rule. So if f at x equals kgx, kg at x, where k is constant, then f prime at x equals kg prime at x. The sum rule, so function p at x and q at x are differentiable, and f prime at x and f at x and p at x plus q at x, then f prime at x equals p prime q of x and q prime at x. And then the last one is the difference rule. So if the function p at x and q at x are differentiable, then f at x equals p of x minus q of x, then f prime of x equals p prime at x minus q prime at x. That's a mouthful. All of that will also be in the document that's attached in the folder to my drive in the lesson outline. Okay, so for example 1, I'm going to start by writing it. Okay, so let's see if you can see this. Alright, maybe I'll use my flashlight. No. So we're going to start with f at x equals x to the power of 2 plus 2x minus 8. So this is a great example because it includes the four of the definitions that I just gave you. So we have here the x at 2 is the power rule. The plus is the sum rule. The 2 at x here is the power rule and the constant rule together. And then the negative here is the difference rule. Right. So just a little brief. So this is what we're starting with for our first example. So I'm just going to rewrite that. So we have f at x equals x squared plus 2x minus 8. So the first thing we're going to do is find the prime of that. So f prime at x equals 2x plus 2. So now we're going to find the local max or min. So the first thing we're going to do is set it to 0. Then we're going to solve for it. So it's going to be 0 equals 2 at x plus 2, which becomes negative 2 equals 2x. So then we find that our x is negative 1. So now we know that our local max or min occurs at x equals negative 1. So now we're going to use the function again here to find the root so we can graph this. So we're going to take that function, so f at x equals x squared plus 2x minus 8, and from there we can get f at x equals x plus 4 and x minus 2. So now we know that we have roots at x equals negative 4 and x equals positive 2. We also know that our vertex is at -1 and -9. So from here we can graph it. So I'm just gonna take a darker one. So here is just -1, -3, and -4. And then down here we're gonna have -9 and 2. So now these are our 2 points because they're our roots, and then our vertex is occurring at -1 and -9. So we know that our graph is going to look something like this on the point, though. Oops, there we go. And then just another overview of it. This will also be attached in the folder. Okay. So finding the tangent at a point, only the x-coordinate is necessary. Also, having the variable on the bottom means we have to apply a negative exponent to bring it all up, all on the same numerator line. Since we have not learned the quotient rule yet. And finally, radicals are the best represented in rational exponential form. So that leads us to our next example, which I'm going to put here again. Okay, so the first thing we're going to do is determine the slope of the tangent at a given point. Excuse me. So the first thing we're going to do is we're going to start with f at x equals 2 over the square root of x. This is also our harder example here. The other one was our easier one. And this is at +2 and -1. Excuse me. Alright, so then first we're going to do is take the prime again. Forgot to write it. So f prime, so this becomes 2 over x to the power of 1/2. And then next, what we're going to do is we're going to change this into f prime equals 2 at x equals -1/2. Just to simplify it a bit more. And then our next step is going to be really important. I'll show you first before we do it. So our next step is going to be f prime at x equals 2 -1/2 x to the power of 3 over 2, and it's negative. I did this example a while back, so I need to keep looking back at it. So this step is really important because the -0.5 exponent after applying the power rule is still subtracted by 1, resulting in that negative exponent of 1.5, the -3 over 2. So I'm just continuing to solve this. So we're only going to solve for x equals +2 from the +2 -1 at the beginning right here. So we're going to take f prime at 2 equals -1 +2 at the -3 over 2. And then this is going to give us that f prime at 2 equals -0.35355. So the slope of the tangent here is -0.35355 with the x equals 2. And then other than that, to finish our lesson overall, the terms that you have learned and you will need to know going on with this unit and past this unit, once again, are the power rule, the constant function rule, the constant multiple rule, the sum rule, and the difference rule. And at the end of this lesson, there's also going to be a quiz that will be uploaded in the same folder that will be the same way I do all my tests with the drive that I'll have it linked.